This is the 6th grade PAP Chapter 9 test review. Number 1. The dot plot shows the recorded high temperatures for 6 days in Little Rock, Arkansas. Determine the mean temperature. Right, so we're looking for the mean. Another word for that is average. So what I need to do is add up all of my values and then divide by the number of values. So I've got two 45s. Add those up. That gives me 90. Then I need to add the 47 to that. 137. Then I'm going to add a 49. That's 186. I'm going to add 50 to that. That's 236, and then the last value is 52. So 236 plus 52 would be 288. And then I'm going to count how many values I had. 1, 2, 3, 4, 5, 6. So I'm going to divide by 6. So 6 will go into 28 4 times. And I have a remainder of 4. I'm going to bring down that last 8. 6 will go into 48 8 times. So the mean, or the average high temperature, is 48. All right, number 2. The graph shows the number of cell phones per 100 people in certain countries. Find the range of the data. So this time I'm looking for the range. That's the highest value minus the lowest value. So this, if I look at my graph, I can see the highest bar here is 166. And then the lowest value here is 75. So if I go ahead and subtract those, 6 minus 5 is 1. Then I have to borrow 16 minus 7 is 9. So the range of the data is 91. All right. On number 2, 6 students kept track of how fast they can run a mile. Find the median of the set of data. All right, so this time I'm looking for median. That's the middle number. In order to find the middle number, remember the most important part is putting your numbers in order from least to greatest. So I'm going to start by doing that. So my lowest score here is 8.78. Then 9.5, I can make that 9.50, so they all have 2 decimal places. And then 9.86, so I've got these two. And then my next value would be 10.44, 11.25, and 12.76. All right, the median is the middle, so I'm going to start front and last, first and last. Okay, and then I can see that there are 2 numbers in the middle. All right, so my median is actually going to be between these 2 numbers. In order to find the value between these 2 numbers, I have to add them, 9.86 and 10.44. So if I add the 6 and the 4, I get 10. Carry the 1. 1 plus 8 is 9, plus 4 is 13. Carry your 1. 1 plus 9 is 10, and then 20. All right, so 20.30, and then I still have to divide that by 2. 2 will go into 2 once, into 0 0 times, bring up your decimal, into 3 once, bring down that last 0, 2 will go into 10 5 times. Okay, so the median of this set of numbers is 10.15. All right, number 4, it says the quiz scores of 14 students are shown in the table. Find the mean, median, and mode of the scores. Okay, so to find the mean, I need to add up all the values. I'm going to add the values that are close together first. So I know that 30 plus 30 is 60. Okay, I know that there are 3 34s, so rather than add them, I'm going to multiply by 3. So 9, 10, that's 102. Okay, so if I add those up, I get 162. And then I have 37 and 39, so I'm just going to add those up. 16, 6, 7, 76. So if I add that to my 162, I get 238. And then I can see I have 1, 2, 3, 4, 5, 6, 7, 45. So I'm going to multiply that by 7, 35, 3. 28 plus 3 is 315. So if I add that to my other values, I have 8 plus 5 is 13, 1 plus 3 plus 1 is 5, and then 5. All right, so that's just the sum of the numbers I still have to divide. Remember, it's mean of S to make you find the mean, or mean is the mean one because you do the most work. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now I need to divide this number by 14. So 14 won't go into 5, it'll go into 45 3 times. The remainder of 13, bring down the 3. All right, and then 14 will go into 133. Let's see. Maybe 6 times 4, 24. No, that's not enough. How about 9 times? 9 times 4 is 36. Carry your 3. Yeah, 9 times 3 is 12. Or 9 times 1 is 9 plus 3 is 12. All right, so when I subtract, I'm going to get 7. Because I have a remainder, I'm going to keep going. It didn't tell me to round, so that means I'm going to keep on dividing. So I'm going to add a 0, bring that down, and then 14 will go into 70 5 times. All right, and then I can stop. So 39.5 is the mean. Median is the middle. So again, in order to find the middle, I'm going to have these in order, least to greatest. Lucky for me, these are already in order, least to greatest. All right, so I'm just going to rewrite these as a line because that's easier for me to block out. Then I have 2 30s, I have 3 34s, I have a 37 and a 39, and I have 7 45s. 3, 4, 5, 6, 7. All right, so just to double check, I know there should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I'm going to do first and last, or beginning and end, however you want to do that. First and last. Okay, and this time I have one value in the middle, so that's 45. I don't need to add or divide or anything. And then the mode stands for the most often, so I'm looking for the number that occurs the most times, and I can see that I have 745, so that's going to be the mode. It's the value that showed up the most times. All right, if I keep going. And number 5, I'm using the set of data to find the measures of spread, and then I'm drawing a box plot. All right, so to find the median, I need to put these numbers in order. I'm going to start with my smallest value, which looks like 6. All right, and then 7, and 9, and 10. And then there are 1, 2, 3 11s. 1, 2, 3. 1, 2, 3 11s. And then I can see there are 2 12s. There's a 13, and there's a 14. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's always a good idea to check to make sure you have the right number of values, because if you don't, that's going to mess up every answer in this problem. It's all going to be thrown off. All right, so the median is the middle, so I'm doing first and last. All right, and I get one number again in the middle, so that would be 11. The minimum is the smallest number in my set of numbers, so that would be 6. The maximum is my highest number, that would be 14. Q1, so now that I've divided my data in half, Q1 is the median of the first half of the values. So because I've used 11 as the median, I'm only going to use these 5 numbers to find Q1. So again, I'm doing first and last, first and last. I get another value in the middle, that would be 9, that's my Q1. Same thing on this side, I'm not using this 11 because it's the median, and then I'm finding the median of the top half of the numbers, so first and last, and that would be 12. My IQR is the difference, is Q3 minus Q1, so it's the range, but it's the range using Q1 and Q3. So if I subtract 12 minus 9, I get 3, so that's my IQR, or interquartile range is what it's also called. All right, and so then to draw the box plot, I'm going to use the values that I just found. So the median was 11, the minimum was 6, the maximum was 14, Q1 is 9, Q3 is 12. All right, and then I'm going to draw my box from Q1 to Q3 going around the median. I have a line through the median, 3, 11, and then I have my whiskers out to the side to my minimum. And so the only value that's not on the box plot is the IQR, but I can find it by just subtracting. Again, if I'm looking at my box plot, 12 minus 9 would be 3. Okay, number 6. Which statement about the data represented by the percent bar graph is not true? There are more male students in third period than in first period. So in third period, the male students is the top part of my graph. So there are more male. So there it looks like from about 50% male students in third period. And in first period, there are from 60 to 100. So that would be 40%. So that is actually true, but I'm looking for not true. All right, 40% of 8th period students are female. So 8th period, the females are the one below, 40%. That looks like that's true. All right, there are less female students in third period than in 8th period. So third period's right here, 8th period's right here. Females are at the bottom, and there are more in third than in 8th. So this is not correct, but I'm going to check the last one just to double check. There are an equal number of male and female students in third period. So in third period, there are 50% female, 50% male, so that's true. So the one that's not true is C. Number 7, which statement about the data represented by the box and whisker plot is not true? So again, I'm looking for not. The range is 10, so that's the high minus the low. So my highest number is 10, my lowest number is 0, so 10 minus 0 would be 10, so that is true. The median is 3. The median in a box plot is that middle value right there, so that would be 3, so that's true. The interquartile range is 4, so that's Q3 minus Q1, so Q3 is 4, Q1 is 1, so 4 minus 1 is 3, so that is also not true, but I'm going to look at the last one just to be sure. The fourth quartile, so that's this range of numbers here, is larger than the second quartile, so that's the range of numbers here. So the fourth quartile goes from 4 to 10, so that's like 6 values. And the second quartile goes from 1 to 4, so that's like 3 values. So that is definitely larger. It's more spread out, basically. So that's true. So C is my value that's not true. Number 8 asks me which set of data has an outlier. Outlier is a number that stands out as being much higher or much lower than the other values in the data set. Someone described it in my class as it's the lonely cow all by itself and when you pass a pasture. So when I look at the range of numbers here, I can see that these are all pretty grouped together, nothing standing out. Here I've got one by itself and one by itself, but they're both right next to another value, so I wouldn't say that they're an outlier. Over here, I have one by itself and one by itself. There's a gap right here, but it's not very far away. And remember, we're comparing it to the median anyway, so both of these values, median's going to be somewhere in here. So they're both about the same amount to the median. And then the last one, if I look at this one, I can see that this number right here is way far away from the rest of it. If I figure the median's like somewhere in here, then this is going to be a lot further away than like this number right here. All right, so 16 is my outlier. So D is the set of data with an outlier. Okay. Table shows the number of people that chose specific vacation destinations they like to vacation. What is the relative frequency for vacationing at the beach? Round to the nearest whole percent if necessary. So relative frequency is just asking you to find the percent. We use percents and percent bar graphs and circle graphs. This one, I'm just finding the percent. So if I'm finding this at vacation at the beach, I'm looking for the percent of people at the beach. But remember, percent is a comparison of part to whole. So I know the part. I know that part of the people, 42 of the people, prefer the beach. But I need to compare it to the whole. So I've got to find out how many people were surveyed. So 10 or 0 plus 2 plus 8, that's 10. And then 1 plus 1 is 2, plus 4 is 6, plus 2 is 8, plus 1 is 9. All right, so when I'm doing percents, I'm doing, again, a part to whole comparison. So if you want to draw your boxes and do it that way, I can do 42 as my part, 90 is my whole, and then I'm trying to find the percent, so that's going to be x over 100. All right, to solve this, I multiply diagonally, so 42 times 100 is 4,200, and then I divide by this last number right here. So dividing by 90, you can't divide 90 into 42, so 90 will go into 420. Let's see, 4 times would be 36. Okay, yeah. So 4 times 9 is 360. And then when I subtract, I get 60, bring down that 0. 90 will go into 600. I'm going to say 6 times, yeah. 90 is 540. When I subtract, I'm going to get 6. If I add a decimal and a 0 and bring it down, I'm back to 600. So 90 will go into 600, 6 again. So I can see that that's going to be repeating. And this is a percent. It did tell me to round to the nearest whole percent, so that would be my ones place. So if I round up the 0.6, it's going to be 47% of people prefer the beach. All right, on number 10, it says use the dot plot to find the mode. Dot plots are the easiest usually to spot the mode. It's just the tallest set of numbers here. Now in this case, I have 2 columns that are the same. So these 2 are the most. Sometimes you have more than one mode. Sometimes you just have one, and sometimes you have none. Like if they're all the same. So here, since these 2 are both the tallest, they would both be considered the mode. So one of these is 5. And then this one's between 4 and 5, so I'm going to call that 4.5. So my 2 modes are 4.5 and 5. So this would be like 4.5. All right, number 11, the double box plot shows the daily number of customers for 2 ice cream parlors. Compare the 2 populations to determine which statement is not true. So again, we're looking for not. A says the lowest number of daily customers went to Sue's Ice Cream. So Sue's Ice Cream, the lowest value is at 20. So that's lower than Corner Creamery. That's true. The range of the Corner Creamery is equal to the range of Sue's Ice Cream. So I need to find both of the ranges. So that's the high minus the low. So Corner Creamery, the high value looks to be about 90. And the low value is at 25. So when I subtract those, I get 65. On Sue's Ice Cream, the high value is 80. The low value is 20. When I subtract those, I get 60. So these are not the same. It says they are. So it looks like that is probably my answer, but I'm going to keep looking. The interquartile range of Sue's Ice Cream is less than the interquartile range of the Corner Creamery. So remember, interquartile range is the IQR, so that's Q3 minus Q1. So if I compare these, I've got 80 for Corner Creamery to 45. And that would be 35. And then if I compare these two, 60 minus 40, I get 20. So this says that Sue's Ice Cream is less than Corner Creamery. That's true. And actually, I can just look at the picture. I can see that this is much wider than this, so that's true. The median of the Corner Creamery is greater than the median of Sue's Ice Cream. So the median here is 70, median here is 50. So yeah, this one's true too. All right, so the one that's not true is B. All right, on 12, it says, which situation does not yield variability? How many days are in June? 30. How many students are in a 6th grade classroom? 25. How many texts do you receive each month? 82. How many babies are born each day at St. David's Hospital? Okay, so which one does not yield variability? So some of these, when you're trying to figure out which one has the most variety in answers, all right, I can go ahead and say that the one that's not going to yield any variability would have to be A, June, because there's really just one right answer to that. If I'm asking how many students are in a 6th grade classroom, it depends on the school and on the teacher. How many texts each month? That's going to depend on the month. And how many babies are born each day at St. David's Hospital? That's, again, going to depend on the day. All right, I'm going to stop the review there, and we'll pick it up in the next video.